Hello. We're going to start with 8127. It says that assuming that a significance level is alpha equals 0.1, so that's 1% confidence interval. Remember, the alpha is what goes in the tail, or tails, depending on what type of test it is. So let's look at the claim. The original claim is that the mean pulse rate is, that means equals 75. So it's a two-tailed test because if the claim is equals, that's where the claim goes in the null hypothesis, which means the alternative is not equal, which makes it a two-tailed test. So we're putting 0.05 in each tail. It's a 10%, so 5% goes in each tail. So they're asking us, do we reject or do we fail to reject? Well, the only thing we reject is when the P is low. Remember, if the P is low, the null must go. Low compared to what? Low compared to alpha, the confidence or the significance level, which creates the confidence interval. So if you look at the P value here, it's 0.0039, which is less than 0.05, which is alpha over 2, because it's a two-tailed test. So since the P is low, the null must go, so we're going to reject. And the one that makes sense is C, because A says that P is greater than alpha. That's not true. We just said that it was less than or equal, but usually it's less than. So check your answer. There you go. Now, if you didn't get this earlier, you can find it on the Homework 9 file, which I will share with you. There it is. And if I enlarge it, you can see, identify the original claim. Well, we did. It said that the mean, or was it the mean or the proportion? Let me just look back real quick. It says the mean. It said that the mean was 75. Well, right there, H not equals. Anytime you have an equals, that goes in the null hypothesis. And just to reiterate here, I see a duck here. There we go. It was enlarged. On page 2, you can see that the new way to do it, to make the decision, is with the p-value. You can see on number F1, it says if the p-value is less than, and there's the ditty, if the p is low, the null must go. So we're rejecting the null hypothesis. So I'm going to go back to the problem. Okay, 8127 coming up. Okay, so I hit OK, and it told us we were correct. Got the green check mark. And then they're going to ask us, without using technical terms, state a final conclusion. Well, don't forget, the way we set up the null hypothesis for the test is that's where the sense of equality goes. That's the form. That's the structure. The claim can be in either place. The claim could be in the null, or the claim could be in the alternative. In this case, the claim was in the null. They're identical. So if we're rejecting the null, then we're rejecting the claim. We can't support the claim. So which one of these makes the most sense? see, it would be number D. There's sufficient evidence to warrant rejection of the claim that the mean pulse rate is 75. We're rejecting that claim. We can't say that it's not 75. We can't say that it is 75. So A and B don't make any sense. And C says there's not sufficient evidence, but that's not true. There is sufficient evidence. We want to reject the claim in the null hypothesis, and that's what they're looking for. Okay, the next question is, I got to get a new 8131. Okay, this is for a type 1 and type 2 error. So here it comes, 8131. So identify the type 1 error and the type 2 error. So first one's a type 1 error. Type 1 error, first of all, if the null hypothesis is true and we don't reject it, we're okay. And likewise, if the null hypothesis is false and we reject it, that's okay. However, if the null is true and we reject it, that's bad. That's a type 1 error, when it's true and you reject it. But the alpha level is what sets that. If you think about it, if you set the alpha level really low, like for a medical analysis, when you do something statistically, on the statistical analysis with some medicine, you want to use a 99% confidence interval, because then the tails are real small. So if you end up in the tail, you're going to reject the null hypothesis for just cause, because with a 1% significance level, a 99% confidence level, you're saying 1 chance in 100 of rejecting the null hypothesis. And that's reasonable. And so if it's even smaller, if the p-value is even smaller, then you're even reducing the chances to less than 1 in 100, which is ideal. So that's what the alpha level sets against a type 1 error. You don't want to reject a null if there's no evidence to do so. So in this case, it says the percentage of students who graduate is greater than 55%. So that's the claim. So it's greater than, so it's in the alternate hypothesis. So the null hypothesis is that it's less than or equal. And in this book just says equal. So a type 1 error would be to reject that when it's true. The only one that states that is B, or no, A. It says reject the null hypothesis when that percentage is actually equal. See, the claim is that it's greater, but if the evidence says that it's equal or less than, then if you reject that data, then that's a type 1 error. That's why we don't want to reject it unless it's absolutely false. Now for a type 2 error, continue, given this same scenario, that's when we are going to not reject it or accept the null when it's false, which means if it's false, then we have to support the claim. So that would be failed to reject when the percentage is actually greater than 55. So that's D. See, it says failed to reject a null when that percentage is actually greater than 55. So it will be D. Check answer. Okay. I'm not sure if I have anything written down about type 1 and type 2 errors, but you can look in the PowerPoints and in the textbook for help on that. But that's basically the idea. So I'm going to stop this video here. That was questions 8127 and 8131. I'm going to go to section A2 now. Dr. K out.